So for part A, we want to find g of 0 and g prime of 0. So notice how g is defined and that we're looking at the graph of f. So since g is equal to 0, at g, all we're going to do is substitute the 0 where we see an x. So we're going to have the integral from -3 to 0 of f of t dt. So this represents find the area under the curve from -3 to 0. So I'm going to find the area under the curve between -3 and 0. And the area is the trapezoid, right? It's base 1 plus base 2 times the height divided by 2. So that's going to be 9/2. For g prime of 0, we're going to use the fundamental theorem of calculus that we're taking the derivative of an integral. So notice we're taking the derivative of the integral. The lower bound is a constant, and my variables match. So fundamental theorem of calculus are inverses, so they cancel each other, and I'm just going to substitute the x. So g prime of 0 is the same thing as f of 0. So what this means is, since I'm looking at the graph, find the y value at f when x is 0. So that's going to be 1. For part B, we're trying to find the relative maximum. So remember that we learned to find a maximum, we're going to do where the derivative is equal to 0 or the derivative does not exist, and the derivative has to change sign from positive to negative. So we already know what the derivative is. The derivative is f, so we want to know when f is equal to 0. So if you look at the graph, f is equal to 0 at 3 places. When x is -4, okay, and notice that since I'm looking at f, I'm looking at the y values. The y value goes from negative to positive. So this is at local min. At x equals to 1, I'm going from positive to positive. So this is neither a local min or max. And at x equals to 3, I go from a positive to a negative. So that's my local max. So I do need to explain this in a complete sentence when you justify your answer. And you also have to explain why the other 2 points are not local max.